Hello, my name is Mackenzie Maxwell, and this is my Lab 1 charged tapes. The purpose of this experiment was to use pieces of tape to observe the transfer of electrons between surfaces causing a charge and to estimate the number of electrons transferred over the surface of the pieces of tape. We are going to be using a tape model to demonstrate these point charges while assuming charges were distributed evenly on each piece of tape in order to apply this to Coulomb's law. And then using Newton's second law and Coulomb's law, we will calculate for the charge of each piece of tape. In the end, the newly charged pieces of tape did repulse each other, indicating a same positive charge. And also, according to the experiment, the charge on each tape was calculated to be approximately 1.4 times 10 to the negative 8 coulombs. We assume that is the same on each tape. And according to calculations, each tape lost 8.02 times 10 to the negative 10 atoms for every electron. The fundamental principles and assumptions for this lab are as follows. The assumptions are that air resistance is negligible, and we are going to also assume that each piece of tape had the same magnitude of charge with an even distribution along the entire length of the tape, just to make calculations easy. And the long tape will act as a point charge with all the charge concentrated at the center of the long tape. As we can see to the right, we have Newton's second law, which is the force of gravity, which equals the sum of the forces of gravity, which is mass times acceleration times our point vector. And then Coulomb's law, which is the force electric, which is our K constant, which is 1 over 4 pi epsilon naught times our two charges, which is Q1 times Q2 over R, which is our location, and also our point vector as well, our hat. More specifically, these two forces will add up to be F net, and we will be able to get our answer from there. This is the experimental design. To summarize, the interactions between point charges were observed on a macro scale using these charge tape pieces, modeling said point charges. The system was the tape A and the tape B, and the surroundings were everything else around that. The initial conditions are as follows as well. There are two pieces of tape approximately equal in length and neutral placed on a third piece of neutral tape on a table. So in total, there are 3 pieces of tape. And by description, step by step, charge the 2 pieces of tape by quickly ripping them off the third tape on the table, and then observe the interactions between the newly charged tape pieces and different objects. This included my hand, which is neutral, and also a negatively charged pen. We're going to stack the charged pieces on top of each other, separated by a distance until the top piece begins to float. We will see a picture of that. I think that was earlier in the slides. We're going to measure that distance d in between those 2 pieces of tape and determine the necessary excess charge via these calculations. The tape mass was around 0.002 kilograms. The tape length was 0.2 meters. The tape width is 0.02 meters, and the distance d was 0.03 meters. These are the calculations as follows, as the picture is right there that I was talking about earlier. We measured the force of gravity, the force electric, and the charge of tape using algebra and using those equations I had specified earlier on the fundamental things. And then the number of electrons lost was also calculated with that new number. We have the area of the tape and the area of the atom and the number of atoms on the tape. That was how we calculated for that. And this ratio was also calculated from that as well. All those calculations come together in the glow script code. As you can see I specified K and the Q electron and a number of other things like the tape mass, tape length, tape width, and gravity and other things as well. I then used those values to calculate for the equations I specified on the previous slide. And you can see many of these calculations as T length times T width divided by the atom length and able to get the atom count. In the end, the tape was attracted to my hand. It was propelled by another piece of tape. The tape was attracted by a negatively charged pen. And in conclusion, that means the tape was positively charged and lost electrons during the charging process. Sources include inconsistencies in the point charges in the model and the physical experiment. This could have been by necessary handling of the tape during setup, and also unequal charges distributed on each tape in reality. Finally, discussion questions. If the electrons had a positive charge and the protons had a negative charge, what would change? Effectively nothing, because all of the interactions between the charges would remain the same. More specifically, the like charges would continue to repel each other, whether they are negative or positive, and the opposite charges would attract. It is important to handle these charged tapes as little as possible because when they come into other objects, especially neutral surfaces like that of your hands, the charged object could potentially neutralize themselves and by receiving electrons that were lost on the surface. Thank you so much for watching.